Collecting like terms. We've covered it before, but now we're going to do more complex questions. It's one of the topics in algebra that must be mastered. I've seen too many students stuff this up. That's why I'm doing another lesson on this. Pay attention. The next couple of examples are going to be easy, but I'm going to make them harder as we go. We're doing about 12 examples. So watch carefully, look, and pay attention to what I'm going to tell you, because I've seen students make mistakes, especially when we're doing more longer addition and subtraction of algebraic expressions, which is called collecting like terms. Let's get started with the first 4 examples. Let's start on top. 6x plus 5x. Remind yourself, what does collecting like terms mean? It means to add or subtract algebraic expressions that have the same pronumerals. We can only add or subtract algebraic expressions with the same pronumerals. So here, do we have the same pronumerals, x and x? Yes, we do. We can add them up. It's that simple. 6x plus 5x, 11x. Yes, that's all it is. Next one, 13a squared plus 2a squared. Well, are the pronumerals the same? A squared, a squared. Yes, they are. They are like terms. 13 plus 2, 15a squared. So very important. Like terms, there they are. 13 plus 2, 15a squared. Here, 15xy. Take away 5yx. Again, we ask, are they like terms? xy, yx. Guess what? They are. Well, the order is different, xy and yx, but the order does not matter as long as we have the same pronumerals, x here and y there. So xy and yx, they are like terms. We can take away 15, take away 5. 10xy. Now you can write 10yx or 10xy. I like to write it as 10xy. That way I can show my English teacher I know my alphabet, x, y, z. So here 10xy or 10yx is still correct. Doesn't matter. 10yx is fine and 10xy is fine. So it doesn't really matter as long as we know they are like terms. 15 take away 5, 10xy. Here, another example, but it's a little bit longer. We have 6a plus 4a plus 2a plus 5a. Are they all like terms? A, and A. Yes, they are. We add them all up. 6 plus 4, 10 plus 2, 12 plus 5, 17. 17a. Very important not to forget to include the pronumerals. So 6a plus 4a plus 2a plus 5a is 17a. Let's do some more examples. Okay, more complex questions now. We're collecting like terms. We have 4q squared plus 5q squared minus 3q squared. Are they all the same pronumerals? Are they all like terms? q squared, and q squared. Yes, they are. We can collect like terms. 4q squared plus 5q squared. 4 plus 5 is 9. 9 take away 3, 6. Q squared. Very important not to forget the squared. We have to write the pronumeral the same way it appears in the question. So 4q squared plus 5q squared is 9. 9 take away 3, 6q squared. Looking here, once again we look for like terms. 2b squared plus 4b plus 3b squared minus 2b. Hang on, what can you tell? We do have like terms, but at the same time we have terms that are different. 2b squared, 4b, 3b squared, and 2b. Where are the like terms? Let's connect them together first before we solve it. 2b squared is a like term with 3b squared. And 4b is a like term with negative 2b. So now that we are identifying the like terms, we can start adding and subtracting. 2b squared plus 3b squared. You notice how I circled the plus, because the plus belongs to the 3. That plus belongs to the 4. Very important rule, we've covered it before. So 2b squared plus 3b squared, 5b squared. And now we do the 4b, positive 4b, so 4b minus 2b. Very critical that you see that. 4b, take away 2b. That plus belongs to the 3. Very important. So 4b minus 2b is positive 2b, because 4 take away 2 is 2. 2 means positive 2. So we write positive 2. Sometimes students think, okay, what sign do I put? Well, if you're doing 4b, you have 4 bananas. Take away 2 bananas. You're left with 2 bananas, 2b. So 2b, it's a positive 2b. So 5b squared plus 2b is our final answer. Can we go any further? No, we can't, because these are not like terms. This is our final solution. This one here, negative 5x minus 18x. Again, we are looking for like terms, and yes, they are like terms. So negative 5 minus 18, again, we're working with negative numbers here. Minus 5 minus 18 minus 23x. So minus 5 minus 18 is negative 23, and of course we put our pronumeral, negative 23x. If you get stuck, you can use your calculator, but I tell students, please rely on your brain. You'll become very good, and you'll be a master in mathematics. Now here, minus 15p. Take away negative 5p. Are they like terms? We have a p and a p. Yes, they are like terms. So minus 15 minus negative 5p. Well, what do you notice? 2 negatives next to each other. We learnt that 2 negatives next to each other, they join forces and become a plus. So these two together become a plus. Negative 15p plus the 5p. So negative 15 plus 5, negative 10p. So our answer for that one is negative 10p minus 15p minus 5p. Minus and minus next to each other, side by side, they become a plus. Minus 15p plus 5p is negative 10p. Let's do another 4 examples. 4 examples, let's go through them. Minus 3x plus 2x minus 3y. Like terms. Minus 3x plus 2x are the like terms. Minus 3 plus 2, what are we going to do? Minus 3 plus 2 is negative 1x. We write it as negative x. We don't need to put the 1, but we know it's there. So negative 3 plus 2 is negative 1x. Negative x, that's how we write it. And then minus 3y. It doesn't have any like terms. So negative x minus 3x plus 2x is negative x. Minus 3y is our final solution for that one. Here we have 8x squared plus 4x squared minus 6x. Again, we need to identify the like terms. X squared and x squared are like terms. X is not a like term for those two here, because that's an x squared, this is an x. Let's go, let's do it. 8x squared plus 4x squared, well 8 plus x, or 8 plus 4 is 12, x squared minus the 6x. This is not a like term to these ones, so 8 plus 4 is 12, 12x squared minus 6x. This is a long one. What are we going to do? Again, we look for like terms. Do this one with me. I want you to concentrate, and I'm sure you can get it right as well. 9p squared plus 3p minus 4p minus 2p squared. Again, we are looking for the like terms. P squared is a like term with minus 2p squared. P squared here, p squared there. And the positive 3p is a like term with minus 4p. So the p squared here are like terms, and the p here is like terms. So 9 minus 2. Again, the minus belongs to the 2, that plus belongs to the 3, that minus belongs to the 4. So 9p squared minus 2p squared. So 9 take away 2, 7p squared. And here we have 3p minus 4p. So 3 take away 4 is negative 1, which is negative 1p, or just negative p. So 3p take away 4p is negative p. Our final answer, 7p squared, take away p. Can we go any further? No, we can't. These are not like terms. This is our final answer. Now here we have a nice long one. We're going to have fun here, and we're going to do it. And of course, we're not going to make any mistakes. It looks long and it looks scary, but we can handle it. 5 plus 4bn minus 2 plus n plus 8bn. Again, we are looking for like terms. The 5 is a numeral, minus 2 is a numeral. So these are like terms. The 4bn, we can see, is a like term with the positive 8bn here. And the n, poor thing, doesn't have any like terms. It stays there. Let's work it out. 5 take away 2 is 3. 4bn, or positive 4bn, 4bn plus 8bn. So 4 plus 8 is 12. bn, and we don't forget plus n at the end. It has no like term, so it just comes down as it is. So 3 plus 12bn plus n. This is our final answer. As you can see, it did look long, but if you follow the same steps as you do in all the others, you won't make a mistake. You'll find it easy. Don't get scared when you see long questions. When you simplify them, it will become easy and you've got an answer. 3 plus 12bn plus n is our final answer for this question.